morning. My name is M.Omidyeganeh. I'm from University of Ottawa. Today I will talk about YAWDD, a Yawning detection dataset. First I give an introduction, and then I will talk about data collection methodology and the basic statistics of the project will be talked about, and then I will talk about benchmark implementation and availability and format of the dataset. Research study shows that drowsiness is a main important problem in driving safety, and it's a state between awareness and sleep. It caused to increase the threat of crash and near crash by a factor of 4. So intelligent monitoring of a driver's signs of drowsiness is necessary, and yawning detection is the first step to do so. Unfortunately, there is no freely available real condition driver yawning detection dataset, and in this paper we try to provide two video datasets of drivers to design and test algorithms and models for yawning detection. As you know, the face has a very non-rigid and complex structure, and its characteristics always is affected by different factors, including identity, face pose, illumination, facial expression, age, occlusion, and facial hair. So a large enough data set is required to include carefully all variations of these factors. We have considered 4 components: camera, environment, participants, and videos, and I will describe about them. We have used the industry partner called Cognitive Corporation's board. Its name is Apex. It is specialized for in-car smart camera systems. We have used Canon digital camera, and the videos we capture has the rate of 30 frames per second, and the frame size is 642 for 80 pixels. We have used 2 locations for camera. In the first data set, we used it when we put it under the front mirror, and in the second data set, we put it on the driver's dash. Here you can see some snapshots of some videos where the camera is under the mirror, and here the camera is on the dash. And the videos were taken in the car during daytime. We have collected the videos from early morning till sunset, and various lighting situations are considered. Also, weather varies from sunny to rainy, and some background movements were in the videos too. And the videos were taken in daytime, and nighttime videos are not collected. And we are working to extend our data set, including these types of videos too. If we want to use the lighting conditions for the nighttime, the videos will be the same, but if the infrared cameras will be used, the completely different approaches are most likely to be used. And during the capturing of videos, the car is parked to keep the safety of the driver. We have asked the driver to sit in the driver's seat, and the seatbelt was fastened. We have 107 volunteers, 57 males and 50 females, and different conditions were considered, for example, wearing glasses or no glasses, and men had a beard or mustache in some cases, and women sometimes has a scarf. And the participants had different hairstyles and different clothing. And all participants have signed an agreement allowing the video to be used for non-commercial purposes, and a subset of them agreed for their pictures to be published in papers, which there is a table in the website that I will introduce to mention these characteristics. We have collected 342 videos. For the first data set, we have captured 3 to 4 videos per person, and each video has 15 to 40 seconds length. And in each video, the driver has one of the states, normal, talking, and yawning. And in the second data set, which we have 2 samples in the last row, each video has about 1 minute length, and we have a single video per person, and in the video the states varies from normal to talking and yawning. Here you can see some samples. Systems. Here we have some information about the statistics. The plot shows the age distribution of the female participants. 14 people had prescribed eyeglasses, 11 people had sunglasses, 40 people had no glass, and 3 people had a scarf, 53 people had a scarf. And the male participants, 35 people had glasses, 5 people had sunglasses, 33 people with no glasses, 4 people has mustache, and 59 without mustache, 7 people have beard, and 56 no beard. And here is the age distribution of them. Also, we have reported our results on and published them into I2MTC conferences in 2011 and 2013, and also we have a journal paper which is under 2nd revision, and we have used and introduced an algorithm which is computationally lightweight, and we have used Viola Jones' theory for face and mouth detection, and we have used back projection measurement technique for yawning detection. We have implemented our idea on the S.Abtahi's board, and we had a demo paper on it. Here is our results, which can be used to compare your algorithms with ours, and this is a demo video. Our dataset can be used in other applications, for example, in yawning detection for pilots and radar operators and heavy machinery operators, where awareness is crucial and important. It also can be used for face detection and tracking, mouth detection and tracking in different lighting conditions and environmental conditions. Our dataset is available by this webpage, and its size is 5 gigabytes. And it should be used for non-commercial use. Two important issues are important for yawning detection systems. One of them is a real condition data set, and the second is an actual in-car smart camera system. The majority of yawning detection research has a problem with these two factors. Almost all of them use the controlled laboratory-based data sets, and also their algorithms are too computationally complex. While we have solved the first issue by publishing our database here, and the second issue is addressed by our results in the conferences. And I hope that researchers can employ our ideas to improve the driver yawning detection systems. Thank you.
Thank you very much. One quick question, please.
Yeah, I'm very curious, how do you get participants to yawn?
Excuse me?
How do you get them to yawn? I mean, do they yawn spontaneously, or do they just pretend to yawn?
How do you make the drivers yawn?
That was really hard because we put them in a synthesized situation, but they try to imitate the yawning.
Okay, so it's imitation, not
Yes,
spontaneous.
no.
Okay.
Okay, thanks again. Thanks to all the speakers. Let's go for a break. We'll meet again in 12 minutes. That's